This video looks at a couple of past paper questions on Newton's laws. Okay, pause the video and have a read through this first part of question 1. Give yourself about 5 minutes to have a go at the answers and then come back when you're ready. Okay, question 1a asks us to describe the movement of the man when the resultant horizontal force is 0. Now we know from Newton's first law that when there is a net or resultant force of 0, then you are travelling at a constant speed. Now he must be moving because he's in the water and he's not just sinking to the bottom. So in this case, he's moving with a constant velocity. Okay, part B. The man increases force A, which is obviously the force he's using to propel himself along. And then we're asked to explain what happens to force B and then the movement of the man. Now you'll notice there's 4 marks. So again, I'm going to suggest 4 bullet points to make sure that we make 4 separate points to explain what's going on. So if we increase force A, then the forces are no longer balanced. So we need to mention that forces are unbalanced. Now, if the forces are unbalanced, then we know that the man must accelerate. So Newton's first law tells us that if we've got unbalanced forces or resultant force, then you accelerate. As he accelerates, then force B, which is obviously drag, is going to increase because the faster you go, the higher the drag. So the drag, and in this case, do call it force B because it mentions that in the question, increases. Now, as it increases, eventually force A will equal to force B, and at that point, we've got balanced forces again. And of course, at this point, this means we've now got constant velocity again. Okay, pause the video when you're ready to read through part C. Give yourself a few minutes to try the question and then come back and have a look. Now this is a little bit more difficult because we've got some graph paper here, but if not, see if you can work out how you would do the question and compare it to the answer I give. Okay, let's have a look then. Now let's have a look at the information we've actually got. So we know that there's a 3,000 Newton force to the west, and they're very handily given as a compass in case we can't remember, and a 1,000 force to the south. So if I'm going to draw this diagram, I'm actually going to start up here in the top right hand corner. Now have a little look because we need to have a scale. So I've had a quick count and there are 6 squares going down and there's 13 across to the left. So I'm going to use a scale of 4 centimetres or 4 squares is equal to 1,000 newtons. Okay, so in this case then I'm going to go 3,000 to the west. So if 4 centimetres is 1,000, I need to go 12. So I'm going to count along 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, now obviously if you're doing this with a pencil and ruler, it will look a bit tidier. I then got to do 1,000 to the south, so I've said that 4 squares is 1,000. 1, 2, 3, 4, and there's my second one. Now obviously you can make this smaller, but the bigger the diagram, then the more accurate your answer is going to be. The second part of the question then is asking us to determine the magnitude and direction of the force. So we're looking for the magnitude and the direction of the resultant force. Now this is a vector, so the resultant force is going to be the one that completes the triangle. Now obviously this would be done a lot better with a nice pencil and ruler, but we're looking along here. So the length of this line is going to represent the magnitude and the angle will be the direction. It'll be this angle here. Okay, so if I measure along here, I'll end up with a length in centimetres, which I then need to convert using this here. So if I were to measure 4 centimetres along, I would know it was 1,000 newtons. Now, if we measure this in reality, we end up with about 12.1 to 12.2 centimetres. When I convert that, I end up with a resultant force of somewhere between 3,100 to 3,200 newtons. Then the direction then, it doesn't matter which angle you use as long as you draw on here which angle you've done and then state down here what it is. So in this case they give a range of 17 to 19 degrees from the horizontal. Okay, or you could measure this angle here from there all the way around there. Okay, but I think it's easier just to measure the one that's easiest to see on the diagram. Okay, give yourself a couple of minutes to read through question D and have a go, and then when you're ready, press play and we'll go through the answer. Okay, this question says what happens if the force to the south on the boat increases? So going back to what we've just done then, we've had a force in this direction of 3,000 newtons, and then we've had a force south direction of 1,000 newtons. And so the question is asking what's going to happen if this force in the southerly direction gets longer. So if we think about the difference between this one here, that's the resultant force we've just calculated. It was somewhere around 3,100 newtons. And then what happens if I change, because I've made the southerly force much longer, then we can see that the resultant force is going to look more like the blue line. So from that diagram we can clearly see that the resultant force is going to get larger and the angle to the horizontal is also going to get larger. So you'll notice there's 2 marks here, and that now gives us 2 things we can say. The resultant force will increase. And don't forget, you can also draw a little diagram like the one I've done, not just because it helps you work out the answer, but also because if you fluff anything, the examiner can clearly see you know what you're talking about. And then we can say we can increase the angle to the horizontal. And again, I would probably label that angle just so that we can be very clear which one we're talking about. A very quick one, this one. Pause the video and decide what you think the answer is, and come back in a second. Okay, so we're looking for this idea that we're going to have equal in size and opposite directions because we're looking at Newton's laws, so it's going to be this box here. Okay, on to the next part of this question. So pause the video and have a go at these questions. Allow yourself 5 or 6 minutes, and when you're ready, press play to continue. Okay, looking at B part 1 then. We've got a diagram of a boat here with a force of 300 newtons forwards and 250 newtons back, and we're asked to describe the motion of the boat. Well, clearly the forces here are unbalanced at the moment, and we know from Newton's laws that if the forces are unbalanced or if there's a resultant force, then it must be accelerating. But don't forget there's 2 marks here, so we need to be saying accelerating, and we need to give the direction, in this case forwards. Part 2 then, the boat reaches land and the resistance force is increased to 300 newtons. So if we go back to our diagram now, this is now 300 newtons, and we've now got balanced forces. So looking at the next part of the question then, it says to describe the motion. Well, we know it's definitely not accelerating anymore because we've already said that. We've got 2 options here. Now, if you've got balanced forces, an object can be stationary, but we know here that the boat is reaching land, so it's clearly moving. So it must be the second one down, which is constant velocity to the right. Remember, balanced forces means that an object can be at constant velocity of either 0, so stationary, or any other velocity. So don't fall into the trap of thinking it's still stationary. Okay, answering the question part 2 that I just said here. Well, we've got balanced forces. There's our first part of our answer. Okay, don't forget there's 2 marks here, but we've already said there's balanced forces. Therefore, we've got constant velocity. Okay, pause the video again to read through part 4. Again, this is a little difficult to do because it's on the screen, so work out how you will go about doing this question and then compare your thoughts to what I actually put down in the answer. When you're ready, press play to continue. Okay, so here we've got another diagram, this case showing the boat being pulled with two different forces of 300 newtons in different directions. It then says, and this is quite important, that the diagram is to scale, and this is a bit of a hint that you're probably going to need to measure something on the diagram. But the first part of the question says add to diagram 2 to show the single force that has the same effect of the two 300 Newton forces. What it's really looking for here is the resultant force. So what it's looking for here is the idea that we've got a parallelogram. So what we need to do is measure how long this line is here. Okay, once we've measured this distance here, we're then going to do a line parallel from here, which is the same length. And then we're going to join it up to make ourselves a parallelogram of forces. Now the resultant force of the two is going to be here. So you can use a parallelogram of forces to work out where this is. Having said that, you don't need to do it as a parallelogram. What you can do quite simply instead is just remember that if we've got two forces which look like this, okay, and we've got two arrows here, then drawing it as a vector diagram, I really should have one going along here, followed by one going down here. So I'm just moving, if you like, this line here, this one here. I'm shifting it along so that I can make a triangle of forces. It's the same difference, I end up with the same answer. So going back to my blue arrow then, in order to work out the resultant force, then I would need to measure that. Now the only other thing which is a bit difficult here, I've got 4 marks. So I'm going to get a couple of marks for correctly drawing my parallelogram or my triangle of forces. Another mark then is for getting the scale right. So having measured this 300 Newton line, I now need to measure this blue line and then use the scale to work out how long that line is and therefore how many newtons it represents. So for example, if the 300 Newton line was say 2 centimeters long and I measured the blue line, I would use that scale to work out how long the blue line is and therefore the size of the force. It turns out that in the mark scheme they're looking for between 545 to 595 newtons. So you see that they do allow a reasonable margin of error there. Okay, pause the video so you have a bit of time to read through question 3. Then allow yourself about 5 or 6 minutes to have a go at the answers to this question and press play when you're ready to come back. Okay, the first part of the question is a definition. It's asking us to explain the term resultant force. So we're looking at this idea then, this is a single force which has the same effect of all the other forces acting on the object. Okay, that's your first mark. It then says describe the movement of the aircraft when the resultant force is 0. So we're going back to Newton's first law here. Remember, if the resultant force is 0, then the forces are balanced. So the object must be moving at a constant velocity, which could be stationary, but we've got forces acting on the aircraft here suggesting otherwise. So we have got constant velocity. Okay, we've now got a calculation coming up. Let's have a look at the information we've got. So the first what we've got is that we have a take-off mass of 320,000 kilograms. We've got 4 engines, each with a maximum force of 240 kilonewtons, and we're being asked to calculate acceleration. So we've got quite a bit to unpack there. So let's start off with this then. So we need an equation which has got mass in, force in and acceleration. So we're going to be using F equals ma. We know then that the force of 4 engines is 240 kilonewtons. We've got a bit of work to do here. First of all, I'm going to do 4 times the 240 to give me 960 kilonewtons in total. Now I also need to remember to get my units right, because it said here quite clearly that I'm looking at kilonewtons. So I'm going to need to multiply the answer by 1,000. So that's going to be 960,000 newtons. So that's my force sorted out. Now I can put my numbers into the equation. So I've got 960,000 newtons equals the mass, which is 320,000 kilograms, multiplied by the acceleration. So to get acceleration on its own, I need to divide through by the 320,000. So I've got 960,000 divided by 320,000, which gives me an answer of 3. Now just be very careful here, because it does say give the unit. There's no unit next to the answer, so don't forget the meters per second squared to get the last mark. Okay, pause the video again and have a look at this last part of the question, and then give yourself a couple of minutes to come up with an answer. Press play when you're ready to start. Okay, so we're told that the aircraft moves along the runway and its acceleration decreases even though the force from the engines is constant. And this is an explain question, not a describe question. So let's start thinking about what this means. So we know that this forward force here isn't going to change, but we know that the acceleration decreases. So let's start off by thinking about what happens as the aircraft accelerates. Well, obviously as it accelerates and speeds up, then the drag forces acting backwards are going to increase. So as the aircraft accelerates, drag increases. So there's our first mark. Now if this backwards force here gets bigger, then what will happen is that the resultant force acting forwards will get smaller. And therefore, as the resultant force forwards is smaller, then we're going to have a smaller acceleration. So remember from F equals ma, if I decrease the resultant force, then the acceleration will also go down. So as the aircraft accelerates, drag increases, the resultant force decreases, so acceleration decreases. That looks like quite a lot to write for 2 marks, but this would be a higher level question.